Okay, so starting this next section, we're going to be talking about similar right triangles. So sticking with the similar part, we have to go through this definition of an altitude of a right triangle, or really any triangle. For, I guess we can cross this out, for any triangle, we're talking about the perpendicular segment from a vertex to the opposite side. Okay, what this is the height of that triangle. So in any triangle, we'll call it dog. I miss my puppy. What we would have is OS is the altitude. Okay, it's the height of this triangle here, DOG. In a right triangle, as soon as we are talking immediately about a right triangle, ABC, we now consider this height to just be AB. So AB is that altitude, or the height. Okay, that becomes the altitude. It's the tallest part that's standing up here. Okay, if we have it going the other way, if you have this other triangle, it looks like this maybe, with a right angle. We have DEF. Now EF is the altitude. Okay, so depending on what we're looking at, it's the part that's standing up, it's that height. Okay. We go on to altitudes in similar triangles. The altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other. Okay, so now we're talking about flipping the triangle kind of upside down, and what they're saying is drawing these perpendicular lines here and becoming these altitudes, so these heights of them. So we're dropping into the right triangle instead, flipping it upside down, and now we end up with this mess right here. And what happens is we end up with three similar triangles. Okay, it's the big triangle to a small triangle, as well as the big triangle to a small-ish triangle, we'll call it. Okay, so the big triangle for this is triangle ABC. ABC. It's going to be similar to I'm talking about the smallest triangle, ABD here. Now I need to match up my angles, so I see that they share angle A here, so triangle A. Okay, I see that angle B in my big triangle is a right angle, so this one is 90 degrees, so I need to find one that's going to be 90 degrees in the smaller one, which looks like it's going to be D, and then I'll have B last. So I have this similarity. I also have my bigger triangle, triangle ABC, similar to the smallish, which is this BDC, and I want to match it up correctly. So I don't have any A at all, so I have to figure out which one matches with A. B is, again, my 90-degree angle, and C they're going to share. So C, I see that C has both red and blue, so I can see that it's going to be something like DC, which means B must go here to match that small-ish triangle. Okay. We move on to the back side. We want to determine which theorem proves triangle ABC and complete the proportion here. So CBD, ABC, so that's the big one to that small one inside, CBD. Okay. I can see that B is in the same spot, so they must share this angle. And then they have angle C. The measure of angle C is 90 degrees in the big one, and the measure of angle D is 90 degrees in the small one, which means I must be using angle-angle. I didn't get any side lengths, so I'm definitely talking about angle-angle. And then I want to compare these. So AC will be similar to CB. Okay, and you can go back here. This is a good opportunity to go back and match these up, A and C. So A is also here. B and C, B and B. B is on top of B, and then C and D. So I have C here. Is that right? A, yeah. So I can see how I can match these. So CD, I see the same as AC. CB is the same as AB, and AB, here I want to match those. Oh, I mess up here. Like this one's, yep, I'm sorry. This one's BD, CB, BD, and then AB, and CB. Okay. And the last one, write a similarity statement for the triangle. So we have options here. We want to go big to small. We also can go big to small-ish, the medium-sized one, I guess I should call it. So triangle L and M will be similar to triangle LP. Oh, nope, I'm on the wrong one. Triangle NP. N. Same for this, L and M, similar to triangle LPN. Okay, match up the right angles. So the reason I can do this here for these two is that the measure of angle N is 90 degrees, and the measure of angle the measure of angle P is 90 degrees. That's why they're both in the middle. And then they're sharing M and M. These two sharing L, and then they have the measure of angle N equals 90 degrees, and the measure of angle P equals 90 degrees. So they have those again in the middle. Okay, so see what you can do for the classwork, get the similarity statements, and solve for some problems.